So if you were absent or you weren't paying attention, one or the other, this is the lab that we did today in class. What you're going to do is go to Google Classroom or the website, because I do have it on the website as well, and you're going to check out how the lab worked. I'm not going to show it to you because I have a whole video that's all set up. So one of the things that you should know when the gal was touching the dialysis tubing, what's special or unique about dialysis tubing is it is semi-permeable. Permeable. So semi-permeable means only some things can come in and out, not a lot. Permeable means everything comes in and out. And impermeable means nothing can go through. So that's why you have like a lead thing put over your neck when you're at the dentist, so that the x-rays, when they do your teeth x-rays, it doesn't hurt your thyroid. All right, so this is page 81 in your book. So nothing I'm saying right now you can't look up. It's already there for you. But we do go through passive transport today, and that's really important. And the words hydrophobic and hydrophilic. If you are arachnophobic, that means, or arachnophobic, that means you are scared of spiders. All right, so whenever we talk about diffusion, and what I did was I sprayed some perfume on myself. And I said, so who's going to be the first person to smell it? So it was all the kids in front. And then, of course, then it diffuses back. So it goes from high concentration. So if you drop dye into a glass, you know it's very concentrated until it becomes equal throughout the entire glass. You're going to need to color, so the directions are all right here on what you need to do. So I'm going to let you go ahead and do that. But now what I really want you to look at is glucose are these, which you already know, they're six-sided. How did glucose get into the cell? So this is inside the cell, this is outside the cell. How did glucose get in? Well, it had to go through a channel. How does oxygen get into the cell? This is really important. Oxygen goes through the cell membrane. Those are things you need to know. Once again, hydrophilic means love, hydrophobic means hate. So you need to fill out this table right here. It's in Google Classroom. So fill out these information. And I'm going to let you copy down the definitions here. So you can hit pause, or you can use the book, of course. So, and this one we're dealing with today is really osmosis. That's the big one, the diffusion of water. Once again, 1 and 2 go along with this picture right here. So you do need to answer, oopsie crud, you need to answer all of those. Okay, so we're going to talk about the difference between a solute and a solvent. Okay, so a solute is something that gets dissolved in water. Okay, so what we're going to do is I'm going to draw 3 beakers. Okay, draw 3 beakers. And in the beaker, we're going to put a cell. And we're going to just draw a big pink cell, and a pink cell, and a pink cell. And in the cell, we have 10% salt. 10% salt. I'm going to put 10% S. Okay? That means, now go with me here, that means that the percentage of water, even though it doesn't always work out this way, we're going to say that this is 90% water. I drew it blue so that you'd know it was water. Okay, so 90% water. Okay, and then let's do 90% water here. Now, we're going to use 3 different solutions. So iso means equal, hypo means below. And in this case, we mean that the solute concentration is below. And I'll explain that in a second. And hyper means above. Like if somebody's hyperactive, they're very, very active. Okay. So in this one, I have a 90% solution. 10% salt. Now remember, water moves, not salt. Well, wait, 90 and 90, what's going to happen? Well, it's going to move both directions. We call this one isotonic. All right, let's move over to this one. Now in this beaker, I have a 95% water, 5% salt solution. Now, remember, water moves, not salt. So we've got 95 and 90. So it moves from high to low. 95 is higher, so this is going to go in. All right? But now water's going in, but when we label this one, we have to look at the salt concentration in order to label this. The solution is lower than the cell. So this one is hypotonic. So water moves in. Moves in to cell. Okay, and remember, we're looking at the salt concentration. So now in this one, we have an 80% water, 20% salt. Okay, let me change colors again. Let's do red. So which one's higher, 90 or 80? Well, 90 is higher, so water is going to move out. So look at the salt content, 20 and 10. This one's higher, so this one's called hypertonic. So water moves out, so the cell is going to shrink. This would be like you drinking ocean water. What? You're not supposed to drink ocean water? I know. All right. So now you need to try to do this part right here, okay? And go back to the lab. If you don't remember, go back and watch the video, and you should be able to answer these questions. And then do the coloring and answer these questions. And once again, it is pages 81 through 83 in your book. Thank you.